Welcome to Unit 1, Lesson 8, the nth term. Okay, let's see how to find terms of sequences directly. Now, the nth term, the setup is a little bit different, but here's the point. Recursive sequences, what we had before was recursive. Recursive sequences are good for first terms of a sequence. First couple of terms. Recursive sequence, the one drawback of recursive sequences is they do not allow us quickly to get any term of a sequence. So in a recursive term, you need your first term and then you need your change. And then you go from the first term to the second term to the third term to the fourth term. You have to go in some order. What explicit or the nth term do, and this is our new thing for the day, is nth term in this curriculum is called nth term. In other ones, it's called explicit. All other use explicit. It allows you to get to any term quickly. You have your little formula and you just calculate it and you get to any term. So I could pull up the 6th term. I could pull up the 100th term. I don't need to go first, second, third. I don't need to go in order. That's the whole point of this one. Okay, which one doesn't belong as a warm-up activity? Look at it, make a argument, make a mathematical argument. Okay, Claire takes a piece of paper with 8 by 10. We did this in class. Then she cuts it in half again and again. We did this in class where we folded the paper. Instead of writing a recursive definition, Claire writes this, where 80 is her original area, 1/2 is the change, and n, our variable, is an exponent called the number of folds. Approximately, what is the area of the paper after 10 cuts? So basically what you do is you put 80, you put 1/2 in, and you put 10 in here. And then you just calculate it. Now, you all have calculators because you downloaded Calculate 84 app onto your phone. And the button to hit the caret, you type it in just like it's written. The parentheses are over the 8 and 9, but the caret key to make exponents is over top the division symbol on the right side. So look for that key over top the division and you can just go ahead and calculate it. And then we have Kieran takes a piece of paper with 8 by 10 and cuts away 1 inch of width. He does it again. So this is not a geometric sequence. This is going to be algebraic. And then complete the table for Kieran's piece of paper, K of n in square inches. So basically for Kieran, we are going to have (80 minus 8 equals 72. Or there's 1/8. And then step 2, you see 80 minus 8 minus 8. And then step 3 is going to be 80 minus 8 minus 8 minus 8. Or 80 times 8 times 3. And then step 4 is going to be 80 minus 8 times 4 because you're subtracting 8 4 times. And then 80 minus 8 times 5. Okay, complete the table. We completed the table. I had to use a shortcut, so because I don't have the space to write that small. Now, Karan says the area after 6 cut in square inches is 80 minus 8 times 6. That is true because we know that addition is multiplying the number by how many times you subtract it. Addition and subtraction is the same thing. Explain where the different terms in his expression came from. Write a definition for Kn that is not recursive. So basically, what we have is K of n equals our first term. We still need our first term minus our change and then n goes in here so that we could calculate any cut. And you don't need to write the first term. You can if you want to. We started at 80, and then we still would like to have n greater than equal to 2, but we'll get to a more formalized. This is a general, we'll get to more formalized. Now, which is larger, k of 6 or c of 6? So for k of 6, 6 is our input. We do 80 minus 8 times 6. 8 times 6 is 48. 80 minus 48 gives us 10 minus 8, 7 minus 4 is 32. Okay, now for c of 6, we have 80 times 1/2 to the 6th power. Put that in your calculator. Is 1.25, and we can see that k of 6 is bigger. Okay, we saw this before in lesson 2 or 3 with the Sierpinski triangles. So count the number of black triangles. We got 1, then we go to 1, 2, 3, then we go to 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 3, 9, 27. Okay, so let S be the number of black triangles in step N. Define S of N recursively. Okay, so now back to writing a recursive sequence. So number 1 is going to be purple. So here S of N equals the previous term times 3 for n greater than or equal to 2. Now all I need is the first term. S of 1 equals 1. So 1 times 3 makes the second term. 3 times 3 makes the third term. 9 times 3 makes the fourth term. Okay, so let's do number 2 in red. Andrea and Lynn are asked to write an equation for S of N that isn't recursive. Andre writes S of N equals 3n for n greater than 0, while Lynn writes S of N equals 3n for n greater than 1. Whose equation do you think is correct? Okay, now this is something we didn't talk about in recursive sequences. They are both correct. It depends on your starting point. Now, when we did recursive, we called this step 1, step 2, step 3, step 3, step 4. Now, what you can do, you can call this one step 0 because nothing is done. And call this one step 1 because something is done to it. Step 2, step 3. So the most important thing is n must be greater than 0. So 0 will be your first one. Anything to the 0 power is 1. So that's where you get that one. And this one, n is greater than 1. So your first step is step 1. 1 minus 1 is 0. 3 to the 0 is 1. So it depends on your point of view. If you want to start with step 0, fine, start with step 0. If you want to start with step 1, then you need the second equation. If you want to start with step 0, the first equation works. You still need that n greater than or equal to something, but we have different starting points for convention. It's just a convention, so don't go crazy over it. Just figure out what to name your first input, 0 or 1. It makes a difference when graphs. Okay, so now what we're going to do is write a definition for this one. So this is times 2. This one is minus 7. Yeah, minus 7. Okay, so geometrically, C of n would be our first term times 2 to the x power. Now, if I call this step 0, I don't need the x minus 1. But If you're used to the recursive way of doing things and you call this step 1 is 1, then you need x minus 1 for n greater than or equal to 1. So make the choice. Is your first number step 0 or is it step 1? Doesn't matter to me. I'll make this step 1. I'll call the next one step 0, and we will see that e of n is equal to 20 minus 7 times n for n greater than or equal to 0. So if 20 is step 0, we put a 0 in, that's our step 0. If we put a 1 in, that gets us to our first term, which is after our initial. It depends on how you look at it. So pick one and stick to it, whatever's easier for you to understand. Now, if you wanted to write this one, you would write e to the n equals 20 minus 7 to the n minus 1 for n greater than or equal to 1. So there's your n minus 1 at this recursive. I think this looks too recursive. I like the blue one, but you had to make your own argument. All right, I can explain why different equations can represent the same sequence. It depends on your starting point. Go back and review the lesson, ask any questions, and go ahead and do the practice problems.